So one of the interesting things about the notification capabilities of FME is it opens a whole new world of possibilities. FME traditionally has done, pulling data from databases, or one could call it static data. Now with FME Server, you can start to pull in real-time data feeds. And so this is an example of one prototype system that was built by our partners in Germany to track and more efficiently use the riverways or the waterways of Germany to move freight. Okay, so basically what they have is they have an FME server in the background. It's getting a number of data feeds. One is on the river. They have sensors, water sensors, to know how high the water is. That's important for a number of reasons. If the water's really low, you have to worry about the draft of the ship, or that's how much is underneath the water. Obviously, you don't want to scrape the bottom. That's considered a problem. And so if the water's higher, you can put more on your ships. Okay. The next thing you have to worry about is they have bridges. So they have a static database of all the bridges. And with the water level and how much is in the ship, you can now tell if, how close it's going to get to a bridge. Clearly, hitting a bridge is, another one of these things that's considered not ideal. And so what they have is they have a number of feeds here. On board the ships, they have AIS, which is the onboard identification system, so they know where the ship is. They know its position, its course, its height, and current draft. They also have a model of on the river. They have a sensor network, so as the ship's moving, they know exactly where it is. And of course, a static database of all the bridges. Okay. Now, what this enables you to do is, it's all about efficiency. Once you have a system like that, you have much more confidence on how much you can put on a ship, because you know the level. When water is low, obviously you're going to always play it safe. But if you know exactly the depth of the water at all the locations and your ship draft, now you can put more cargo on that freighter, being confident that it's actually going to make it down the river safely. Conversely, if a ship's too high, you can tell the captain right away, and he can always take on more weight to make sure that he navigates the river. So just like the CN case, this is again about how can we use our networks, our transportation networks, more efficiently using FME Server, and also avoid potential disasters. In the CN case, if you notice the slope is changing on track, that's not a good thing, and you might be able to identify, we need to fix that right away because we could have a derailment. Here, it's okay. We got to take water. We got to tell the captain. We got to pull that ship to port because he's not going to make it under this bridge, or we got to pull it aside and take more freight off. Okay, and the way the captain's notified again is he registers for this, and he's going to get, with FME Service. Well, how would you like to be notified? Do you want an email? Would you like an SMS? Do you have an application on your mobile device? How would you like to be notified? And that's really what it's about. Okay, so the data feeds come in a number of fashions, and again, the OGC interfaces, SOS, SES, they're basically slinging XML documents, so we can connect to one. In the case of SOS, it's a polling architecture, so we ask the sensor for the data and get the XML, and again, ripping it apart to decode it is no problem. SES is a push type of sensor network, and again, we don't really worry about the XML package itself. With FME, it's very easy to do that. And so the big thing here is, this trigger notifications. Again, the captain doesn't have to be watching as much. People can think about other things. He's going to get notified if there's a problem, which makes for a much safer and more efficient use of the transportation network, which in this case the rivers. Okay.